Now we are about to start the program. I invite Professor B.V.R. Chowdhury, Professor K.V.R. Murthy, Dr. Anjana P.S., Professor Hubert Joy, Professor N. Gopakumar to occupy their space on the dais. May I invite your kind attention, everybody? We all are on a 55 crores 20 feet turbocharged cruiser sailing the next 7 hours through Punnamada Lake, which is through the heart of two main districts of Kerala, that is Alappuzha and Kottayam. Welcome to Star Cruise. Myself Midun, 2nd PG Physics SD College, greeting you with a charming good morning and welcome on board. Every program begins with the blessings of ultimate energy source. Let us welcome Anjali Ashwati Ganga from SD College for a short prayer.
सदाशिवसमारम्भाम् शङ्कराचार्यमध्यमाम् अस्मदाचार्यपर्यन्ताम् वन्दे गुरुपरम्परा श्रुतिस्मृतिपुराणानाम् आलयं करुणालयम् नमामि भगवत्पादम् शङ्करं लोकशङ्करम् शङ्करं शङ्कराचार्यम् केशवं बादरायणम् सूत्रभाष्यकृतो वन्दे भगवन्तो पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः दक्षिणामूर्तये नमः दक्षिणामूर्तये नमः.
We all are always open to knowledge. Despite conducting this program in a four-walled closed environment, we have gone for an open and free atmosphere to make this program a much interesting and unforgettable event. Yes, the International Seminar on Luminescence Material conducted through 9 and 10 December 2022. This program is organized by Department of Nanoscience and Nanotechnology, University of Kerala, Sanatana Dharma College, Alappuzha, Mahatma Gandhi College, Thiruvananthapuram, and All Saints College, Thiruvananthapuram. This program is conducted in collaboration with Luminescence Society of India (LSI), founded in 1990, providing a forum of interaction for Indian scientists and technologists with affiliation to different universities and research institutions in the field of luminescence and their application by organizing annual conferences regularly. Once again, welcoming you all to the backwaters of Alapi.
Now, let us cordially invite Dr. Anjana P.S., Head of Department of Physics, All Science College, Trivandrum, to conduct welcome speech.
Good morning, all of you. A warm welcome is never complete without warm words. I am happy to welcome you all to the International Seminar on Luminescence Materials ISLM 2022 in the interest of the organizing committee in this houseboat, which is the Punnamada Lake of Alappuzha. The speciality of this event is that all the activities of the seminar is confined in this houseboat itself. We have planned to conduct in the house hybrid mode owing to the constraints in limiting the number of participants. We are expecting around 100 participants in the offline mode and around 50 participants in the online mode. As all of us know, Luminescent Society of India conducts national and international seminars regularly in different parts of India to orchestrate the research in the field of luminescence. We are very thankful to Professor K.V.R. Murthy for giving this idea of convening this seminar in Houseboat, as well as the opportunity given to us to host this seminar. Before we kickstart this function, I, on behalf of the organizing committee, would like to welcome our guest of honor, Professor B.V.R. Chowdhury, a Senior Executive Director and President Emeritus, Materials Research Society of Singapore, and Adjunct Professor, National University and Nanotechnological University, Singapore, who is stalwart in the field of material science. In spite of his busy schedule, he has taken his precious time to grace the occasion with his presence. We all are eagerly waiting to hear from you, sir, and once again, uh, welcome you to this function. It gives me immense pleasure to welcome Professor K.V.R. Murthy, the President of Luminescence Society of India, who has been the driving force in organizing this event. He has put tremendous efforts in coordinating activities related to the luminescent research in India and abroad. I welcome you, sir. I take this opportunity to cordially welcome the coordinators of the seminar, Professor N. Gopakumar, Controller of Examinations, University of Kerala, and Professor Hubert Joe, Head, Department of Nanoscience and Nanotechnology, University of Kerala. We are fortunate to have the support of a great number of institutions. With mutual collaboration and skillful approach, together as a team, we could arrange this event. I take this opportunity to welcome the entire organizing committee, faculty members from SD College Alappuzha, Mahatma Gandhi College Thiruvananthapuram, All Saints College Thiruvananthapuram, and Department of Nanoscience and Nanotechnology, University of Kerala. And also special thanks to the co-conveners, Professor H. Padmakumar and Dr. S. Reshmi, the heads of the departments of Mahatma Gandhi College and SD College. And I wholeheartedly welcome all faculty members, academicians, industrialists, and students to this event. Your active participation is important throughout the session. I ensure the seminar will be profitable and the next 2 days will be enjoyable and fruitful for every one of you. Thank you. Thank you.
To spread the light of knowledge, I welcome Professor B.V.R. Chowdhury, Professor K.V.R. Murthy for the lamp lighting ceremony. We humbly request everyone to keep their phones in silent mode. Kindly cooperate. Once again, we request everybody to keep their phones in silent mode. Now, for the release of book and abstract, once again, I welcome Professor KVR Mukti sir to hand over the book and abstract, and Professor BVR Chaudhary sir to receive the abstract and souvenir. The chief guest of today's program, Professor BVR Chaudhary, Senior Executive Director and President Emeritus, Material Research Society of Singapore. His contributions for the NTU with Indian University is very notable. He has received many awards from the state government as well as Officer in Order of Academic Palms by the French government and even Ambassador 2010 by the Singapore Tourism Board. He was the adjunct professor at National University and Nanyang Technical University, Singapore. I welcome Professor BVR Chaudhary sir for his wonderful words.
Good morning, everyone. I must join the organizers in welcoming you for this exciting place at the venue, and more importantly, the seminar that is being organized. Of course, I take this opportunity to thank the organizers, particularly the president of the LUMINESCENCE Society, Dr. Murthy, and the entire team for inviting me to this place and to this conference. This is not the first time I have come here, but I was here before. But honestly speaking, if this is not the venue, maybe I would have not considered to come back. Because this place and the venue is so exciting, I should tempt myself and decided to come here. And I'm again very, very happy to be here, and particularly to see a lot of young people here and pursuing the subject of materials or material science, and in particular the luminescence technology. Now I have a brief presentation. Actually, I'm not supposed to give a presentation, but at the same time, as Murthy said, you are the oldest of the lot here, or if you want to be a little more dignified, senior most of the one here. So can you share your experience a little bit about what the society expects from the future generation or the present generation, particularly from the sustainable development point of view? Now, the title I have chosen has three important aspects: materials, of course, all of you are working on materials and you aspire to be leading material scientists of the India and the world as a whole, then the objective essentially to serve the humanity. And in between, I brought up the topic sustainable development, and about which you must have heard a lot from different people. And so, what possibly I might say, or I'm thinking to say, is likely could be the repetition. So, the next slide will give you little idea about what I intend to focus on, because the subject, this title is really very broad, and people can talk hours and hours and days, and each aspect is specialized by itself. But however, I will touch upon few important points. The next slide really talk about what are the things probably you would like to take back as a message, and what are the sustainable, what do we understand by the sustainable development, and what are the goals the present humanity has to take care or arrive at. Then role of materials in achieving these goals. I'm sure you will all feel proud to be material scientists and working on materials. Of course, the specialized technique would be luminescence, but there are many other techniques definitely that are involved here. And what are the challenges we face, particularly societal challenges? There are many things that we should understand. It's easier to say than done. So if anything has to finally, if we have to achieve, society also has to contribute. There are many things we as a material scientists, particularly the young generation, has an important role to play. And at the same time, it also gives us some opportunities and responsibilities. So these are the four different points I'm trying to touch upon. The next slide, of course, will talk about the materials itself, and we all feel proud that we are part of the materials. And I don't have to talk about the importance of the materials. In fact, the human development itself is named after the materials. You must have heard Stone Age, Bronze Age, Copper Age, Silver Age, etc. So this really gives where materials stand. So the materials have been receiving the importance generations and generations. And of course, what is the focus? What should be the focus, or what is the current focus of the research and development in materials? Design of the new materials. Suppose you are studying luminescence. What is the purpose? Of course, to show the how you can make use of the material for a particular purpose, and based on that, you will try to design the materials for a special purpose. Design of new materials and providing knowledge base for the material selection and performance in different aspects. Some I have listed here: energy, environment, health, medicine, information technology, and many more. If I have missed out anything, it is not intentional, except that I want to keep the list short because we will not be able to cover everything. So essentially, we know what is the focus of the research that is currently being carried out, not only in India, in the whole world. So the design of new materials and tailor the materials for a particular purpose and create database for specific applications like energy, water, healthcare, and so on. Now, of course, the new materials have also led to technological revolutions. Again, I have quoted a few examples here. Nylon for fashion industry, silicon chip for information technology, biomedical materials for healthcare, and many more. So this is essentially the materials that have led to the new technological revolutions. Obviously, this gives us new opportunities. So any innovation in materials offer exciting and entrepreneurial opportunities. Particularly these days, the young generation wants to have the startup, wants to create a company, and of course contribute themselves to the society, to the community as a whole. So therefore, you could see there are many opportunities that you have by being a material scientist, by working in interdisciplinary area like science. Today, majority of you may be in physics department. I also started my career probably before any of you or most of you who were not born as a physics student. And then, of course, today I can say I work in chemistry, I can work in physics, I work even in biology and material science as a whole. The next slide will also enable us to convince ourselves that the materials are technology enablers. Otherwise, nobody will respect the material scientist, nobody will pursue the material science, research or innovation, entrepreneurship or whatever it is, unless they are technology enablers. For example, you would agree with me, there would have been no information age without silicon, no mobile phones, what we refer as information age again, without functional ceramics. I know some of you may be working on ceramics, and no aviation industry. Of course, we all travel long distances today. The world has become one. We're able to reach from one place to another place so closely, easily. And in other words, the human beings are brought closer in the real space through the developments in aviation industry. And that could have not happened without aluminum alloys. If you take any airplane, mostly you will see that happening. And of course, no skyscrapers without steel beams. And of course, here many are low-rising buildings. But in a place like Singapore, which is a concrete jungle in a way to some extent, large, very high floors, 70 floors, 80 floors, etc., higher the level, considered to be better in a way. And no direct conversion of the solar power to electricity. Again, sustainable substitute for fossil fuels if photovoltaic materials did not exist or perform well. So you could see, I'm trying to convince you once again that the materials are technology enablers. The next slide, I will touch upon again few aspects. Particularly, we are hearing a lot about global warming, CO2, and all kinds of things. And because there are many challenges also in all these things. So, environment is one aspect that I'm going to look at it, and particularly what are the important research and developments and what are the concerns. So, essentially, from the environment point of view, development of highly efficient, low cost, and environmental friendly electrochemical energy conversion device or storage device for powering portable electronics for electric vehicles and hybrid electric vehicles. Today, the entire issue related to the global warming is probably put the blame essentially on the pollution we are creating through the industrial development and so on. So essentially we are using fossil fuels. Now there is a trend to move towards the renewable energy and so on. Use electric vehicles, hybrid electric vehicles and so on. But there are several concerns also in this. As I mentioned before, we know the problems, we don't know how to solve the problems, we don't know the solutions. And if one solution is good for one, maybe but it's not good for another. There is a dramatic increase in global population. Of course, this is a known number, 8 billion. Probably may not be even the correct number. So there is increase in the burning of the fossil fuels to support growing energy needs. We have become so much used to use energy for every small thing. The mobile phone you carry, not one, two, three. In different pockets you have different phones. So all consume energy. So essentially there is increase in the energy consumption, which is produced normally by the burning of the fossil fuels, and there is an increase in the quantity of CO2. liberated, particularly in production aspect. So therefore, we have to make sure that the materials must be sustainable. So what we are enjoying today, if they have to be enjoyed by the future generations, and I would say that one has to act for it. And in principle, the present generation is considered to be the custodian only, not the owner. You have no right to take away on the name of the ownership. Instead, you have every responsibility to pass on to the next generation in a better form even if possible. And now I will touch upon the sustainable development, what we mean by that. Particularly when we are talking about using the materials, we have to conserve the materials, we have to substitute the materials, reuse the materials, repurpose the materials, and recycle materials. So many aspects are there in this. Each aspect by itself is a very specialized. So effectively, if we want to use the materials effectively, usefully, these are the we want materials to sustain for the future generation. We need to make sure to conserve, substitute, reuse, repurpose, and recycle them. Then similarly, we also have to look at the materials life cycle. I'm sure you know what we mean by the life cycle. What is the input? What is the output? Input are the raw materials and the energy sources, and output of the air emissions, water emissions, and solid waste. All these things we have to take into account if we are going to have the sustainable development. Then, of course, we have to replace the materials, particularly scarce materials, some materials shortage. Then we have to ensure to find a way of replacing them. And we also have to work on the materials economics. You can't say I will spend $1 million and I will produce 1 gram of a material. We have to make sure it work out economically viable. Then lessen the lessen the undesirable environmental impacts from technology and economic growth. This is something most important. So we have to make sure take care of the corrosion, pollution, toxic waste, etc. Minimize the problems with the fossil fuel technologies and find materials for energy efficiency. Of course, similarly, if you are talking about water, which is very, very important, water purification, how to do it, and all those things. You can list again number of things in here. Now, what are the challenges we face? Of course, as I said before, easier to say than done. Then, what are the challenges we face? The changing human behavior. If you think of our parents, grandparents, etc., they didn't have cars, they didn't have any mobile phone. They were physically, mentally, they were very strong. Today, we all have become sitting before the laptop or iPad or a mobile phone, and there is no real physical exercise or any such thing. So, essentially, there is a lot of change in the human behavior, I would say. So, but the technology alone is not going to answer the problem. So, we need to really include the governments, policymakers, scientists, uh, technologists, and industrialists, and must develop their national and global governance policies, practices. But 10 most important global issues that are facing the 21st century, as I mentioned before, energy, environment, healthcare, water, food, pollution, population, security, poverty, education, and deforestation. So these are all, you can say, list them like this, but I would say most of them are interrelated. The next slide will say, for example, you want to educate the child. You can't educate the child who is hungry, who has no water to drink. So effectively, you have to solve the problems with the food, you have to solve the problems with the water, and make the child happy before you even start thinking of educating the child. Similarly, there is an increase in population, which means increase in energy consumption, increase in greenhouse gases, and which has a great effect on the climate and the environment. So this leads to the increase in the materials consumption, which means again increase in packaging materials, increasing solid waste. The solution, of course, is recycling. And material-centric issues critical for sustainable future. Again, I am listing few here: energy, transportation, housing, materials resources, and health. And talking about the material-centric challenges, particularly I will try to focus a little bit on energy, which is of my personal interest. My research interest is of the energy storage, lithium-ion batteries, and so on. So there is increase in efficiency of usage, especially in housing, buildings, and in the industrial sector. We have to shift from the fossil fuels to renewable energy sources, and the renewable sources of energy, biofuels, geothermal, etc., are not sufficient. So we have to move on to the solar power or biofuels and wind power. And naturally, the nanostructured materials are coming into the picture like anything. Photovoltaic materials are playing an important role. Next slide. And if we are thinking of the transportation, of course, we need electric powered vehicles. Lightweight structured materials are developed. And housing, if you are thinking of, one must use environmentally caring, energy efficient, and affordable construction materials. And if you are thinking of the materials resources, normally the materials waste is either burned, emitting pollutants, or deposited in landfills, distributing toxic substances into groundwater and soil. So this deprives materials contained in the discarded materials as objects for productive use. So obviously this means the materials need to be recyclable, biodegradable, and the remanufacturing of components and spent products to new products is needed. Thinking of the health, of course, biomaterials play an important role, implanted medical devices, etc. Now, what is the current status? Of course, as I said, these are all the things we know, but essentially, I would say this part of the country is relatively much better. If you go to Mumbai or Delhi or big cities, you can see again as concrete jungles. You have only built environment, and we have really spoiled the natural environment, which even resulted into the collapse of the several civilizations. So the current industrial age human values and practices have led to built environment that has created an approaching ecological crisis, causing unprecedented greenhouse gases, deforestation, desertification, depletion, and pollution of water sources. Next slide. So, in other words, the society play an important role here. The society must play balance between the natural and built environment. Nobody would advocate to not to develop, not to have technological revolution, not to use modern technologies, but we have to try to balance between the two. So, advancing green economy requires greater awareness of the problems through education, change of lifestyle, and so on. So, in other words, we have to ensure that the people move from brown economy to the green economy. And of course, that depends on the human factor. So, green lifestyle we are talking about is a key to revitalizing the natural environment. So, the lifestyle has to be changed. So, they include three R's, that is reduce, reuse, and recycle the materials. So, sustainable urban working, living, playing, and sustainable technologies, smart buildings, transportation, etc., are very important. The next slide. So, to attain a green lifestyle, human behavior has to change. So, for this, all of us are going to play an important role. We are all, to some extent, today we are all in the education field, either as a student or as a teacher, as a professor or an administrator or whatever it is. So education plays an important role. So what do we need to do? We must educate the educators, educate the students, educate the public, and more importantly, educate the policymakers and the government. So that's the real challenge. We have to educate the government and educate the public and so on. So coming to the innovation aspect, again, as I mentioned before, some of you are aspiring to be innovators, and so innovate something that is useful for humanity. I mean, research and innovation play an important role in the sustainable development of humanity, and a very small fraction of our research led to innovation and startups. And those of you who are involved, if you have, even you may have do 100 papers, 200 papers, 400 papers, have high attendance and citations and so on. But when it comes to the human usage of what you have done, very limited success. And particularly when you want to innovate something, my message is innovate something that is simple, useful to humanity. For example, think of man has put suitcase on the wheels. You know, you're all using the whatever cabin bag or big suitcase or whatever it is on two wheels, four wheels, whatever it is. So man has put the suitcase on the wheels before we have put the man in the space. Man in the space, of course, has given to prestige to the country, give the new knowledge and so on. But if you want to be a successful innovator, that is not what is going to help you. Something to innovate what is simple, feasible, less expensive, and of immediate use for humanity if you want to be a successful innovator. I have taken this example of the suitcase, and of course, it didn't get any awards or patents or government recognition or anything, but it is used by young or old or child or name anyone. They have a suitcase with wheels. Okay, the next slide will probably coming from Singapore. Of course, if I don't do some little publicity for Singapore, I will be doing injustice to Singapore government and Singapore universities. So I just want to tell you, you also need support from the government when you are talking about the sustainable development, environmental issues, etc. So, for example, we have a low carbon energy research funding initiative, and which helps us to raise the funds for the research, and you are able to contribute. So of course, Singapore, those of you who have been to know, is the world's densest but greenest city. Earlier I said concrete jungle, but at the same time it doesn't mean it's not green. It is highly recognized as one of the most important green cities in the world. In fact, American Express has probably listed as the top, one of the top 10 beautiful campuses and green campuses. Of course, Singapore sets firm targets for greener buildings and solar power usage, recycling rate, etc. Eventually, because some of you are in the administration, or some of you may be administrators tomorrow, there are certain things which are probably can be considered as your responsibilities to ensure that we move in the right direction. The next slide. I won't take much of the time. Again, some of you may be looking for the what next after the PhD or masters or whatever the degree you are pursuing. And Nanotechnological University, from where I am coming from, has a special initiative called India Connect. It helps a great deal to encourage Indian students to come to Singapore. We have different intakes. We also organize joint symposia, faculty exchange, joint PhD program, and we organize India Singapore hackathon, and then of course we organize relief programs, etc. So this is how we involve India quite a bit, and so far I'm responsible for all these things to some extent. But in any case, I would say that there is a great opportunity for some of you who wish to pursue your higher studies or collaborate with research or whatever it is. There is an opportunity in Singapore. The next thing, again, this is my personal affair to some extent, and as a president of the Materials Research Society of Singapore, about 20 plus years ago, I created this series that is ICMAT series, International Conference on Materials for Advanced Technologies, and some of you have participated in that, I know, and we have done 10 editions, 11th edition was to be done in 2021, but could not be done due to the COVID. And now we are going to do it in 2023. And together with the International Union of Materials Research Societies, International Conference on Advanced Materials, and the dates, the last week of June, 26th to 30th of June 2023, and the venue, Suntech Convention Center. And as of now, at least I can say, when I say as of now, there could be some changes, but we do have the confirmation as recently as a week ago, and from two Nobel laureates, 8 plenary lectures, and 2 theme lectures will be there. We will talk about different eight themes, and we expect to have possibly around 2,000 participants. And this is little lower than the former conference that were attracted. But because of the COVID, things have changed slightly. Still, there are some countries from where people are not able to travel, or if they travel, they have to go back and do quarantine. All these things. We are targeting for about 2,000 participants. And I would love to see each and every one of you in Singapore. You're all material scientists. I'm wonderful. I'm very sure you'll find a way of going there. And in fact, those of you who are strong, you can even swim. There is a possibility you are on the coast. Singapore is an island again. You can swim, but you will not necessarily do that. There are regular flights, even from Kochi, even from Trivandrum, and of course, name other big cities, no problem. So I would welcome you all there. With this, once again, I would like to thank the organizers for giving me this opportunity and particularly asking me to inaugurate this conference, and wish you all the success with your endeavor, whatever you are going to do, pursuing research, pursuing teaching or entrepreneurship, whatever it is, and wish this particular conference very productive and successful, and hope the Luminescence Society will take lead and organize it at least every alternate year at the same venue. So we are from that. Thank you.
Thank you for your unique and unparalleled words, sir. It was an eye-opening experience for us. Now we invite Professor N. Gopakumar, Controller of Examination, University of Kerala, to hand over our token of appreciation and love to Professor B.V.R. Chowdhury. Now, for the address and keynote, we are pleased to invite Professor K.V.R. Murthy for his mindful words.
Yeah, good morning to everyone. I welcome other participants and my fellows from the Society of India, physically present Dr. Giribabu, Dr. Hanna, and listening through network, other members, Secretary, Luminescence Society of India, Treasurer, and others. Yeah.
Hello. So we are fully loaded and the sailing has started. Along with the words, please also enjoy the ride.
Yeah, ride with science. So this is the theme of this national seminar on luminescence materials. In February, I came for a PhD by Gopakumar. And I thought, let us go for a night to the houseboat. We came. After dinner, I was looking into that. So many big boats are going and people are dancing and singing. Why can't we organize an event? See, this event started February 22 to December 22. So, Dr. Ranjana as a convener, she used to work up to 1 a.m. I start from 2:30 a.m. This continued last 2 weeks. So last week itself we got, from 1st December to 3rd December, we got around 48 abstracts, editing, putting, and talking to them and so many things. So finally, we got a very good small book of abstracts. So I thank the local organizers, including everyone, to brought the book of abstracts in an excellent way. I did everything, but finally they had to do the local one. So here, 1990 January 12th was the foundation of the Luminescence Society of India. I was a founder member, and I just submitted my thesis. Today, after 32 years, 33rd year is coming, I am going to retire next year. So, my journey with Luminescence Society of India was almost 5 international conferences. This is the 4th international seminar on luminescence materials. 2009, we organized Bangalore. 2015, I organized Baroda. Professor Chaudhary was with us. 2017, we organized Singapore, NUS, National University of Singapore. And because of COVID, we could not organize. 2022 here. As he said, they will alternate year. So we may do 24 here itself. 24 and 25. Okay. The advantage and disadvantage both are here. The advantage is that participants are confined. No shopping, no roaming. They are here. They have to listen, there is no option. Okay. It may be a bit expensive, but this time we don't have much money. So next 2024 or 25, we try to get some money. We can support the research students. Normally, the society, the society always supports the research students by giving you free accommodation or supporting the travel, maybe sleeper class after 3 days. So this time, only Department of Science and Technology sanctioned 75,000. This houseboat itself costing us 3.6 lakhs. So we have the 75,000 component, less than 20%. Anyway, society is there to take care of many things, and my members are there to support. And Professor Chaudhary, as a president, he supported the poster awards. So we take that poster awards and oral awards from MRS, Material Research Society, Singapore. So I thank Professor Chaudhary to kind enough to support this poster awards, and his presence here gives a great advantage to the juniors just to join or completing PhD students. Okay. So he is such a renowned and so much experience in the material science globally. So let us go to the. Every time I used to give keynote to some X, Y, Z and others. This time I thought, why can't I speak? The origin of luminescence. If you see the history, 1640 Robert Boyle had some luminescence he got from diamond. That was well documented. And Chinese misused the fireflies. This is a basic bioluminescence. 5,000 years back. This is well documented. They used to carry the fireflies in the lantern night time while traveling to the forest. So one should understand a lantern. Lantern is a metal body and a glass. So that means glass technology was existing in those days. Metal technology was existing in those. So then only fireflies we can keep there and we can see the light. So from that 5,000 years is accepted. Let us see that is a literature in there. So luminescence, a tool for many research areas. Next one, please. Before going to other applications, you see this. The basic definition of luminescence is absorbing of high energy radiation, maybe from hard gamma to hard UV, and giving light in the visible region 380 to around 700 nanometers entire visible spectrum. That is the basic definition of luminescence. Okay, so why this slide is, you see that right side, what are the energies we are receiving, up to what atmosphere they are coming and absorbed. This answer we'll get in the last slides. So what are the white is there, that the light is directly falling on the surface of the earth. Others are absorbed at different places. Okay. So cosmic ray, they say that it is absorbed in the atmosphere, but some cosmic rays are found 8,000 meters depth in the sea. When I was working in 2005 in one of the laboratories in France, our walls are 1 meter thick. Still, we used to uh, detect the cosmic rays. So the detector is maintained at liquid nitrogen temperature. Still, it is a lot of cosmic rays we used to detect. So the cosmic energy definition, I don't want to go inside. Only white light, we see that how much it is falling on Earth. Other things, so Dr. Girbabu will tell much about that. Next one. Next one. Why a luminescence fellow is talking about a black hole? Adjacent light, central black hole. Next one. See the definition. Detection of unusually bright X-ray flare from Sagittarius, a black hole, the center of Milky Way galaxy on 15th January 2000. So he showed that there is a bluish green color. The definition says X-rays. Next one. Okay. So the black hole is a region of space-time where gravity is so strong that nothing, including light or other electromagnetic waves, has enough energy to escape. It is a beautifully written English. Other way around, we said that black hole absorbs everything. As simply we tell those students. So beautifully written. It doesn't have energy to escape from that. So here another statement is here. This temperature of order of millions of Kelvin for stellar black holes, making it essentially impossible to observe directly. So there is no see anything unless some media is there to reflect. We cannot see the light. Unless some media is there, we cannot listen the sound. Next one. So collapse of black holes. So it is collapsing. It is not blasting. So what black hole is collapse inside and two sides funnel. It gives the energy. Energy means all the energies, including the particles. Since it is in a plasma state with the millions of degrees Kelvin temperature. So you see the sky, the beautiful sky of Earth, and then basic luminescence phenomena observed and explained by French scientist Thiruvananthapuram. Wherever you see the phenomena of luminescence, where it is fitting, you see that. That's all. You understood the luminescence. You have to fit this Jablonski emissions through your work. Finally, somewhere heat is released, absorbing a high energy, giving luminescence in the visible region, light in the visible region. What about remaining energy? Remaining energy, nothing but heat. How, where we find that, we discuss. Next one. Oh, these are the general. I can give a number explanation on this. So, generation, first generation is fireflies, forest fires, to latest OLEDs and LEDs, white LEDs. Next one. So, this is a research field where luminescence person will do. So, here see that whatever we are getting is a 10 over 4 gamma to up to ultraviolet X-rays, hard X-rays, ultraviolet, what I meant. So visible is only small one. Infrared, other things we are least bothered. So infrared also, part of infrared also we receive on the yeah. So infrared leads a lot of heating. Next one. Next one. See that. In that X-ray we talked. Now what I am talking, luminous Milky Way. Earlier electromagnetic spectrum, what I showed, what is the energy of X-ray? Energy of X-ray, can you see with eye? If X-ray is falling on some of the materials, ionization occurs, electron hole pair occurs, leads luminescence. A Milky Way is basic, fundamental, luminescence, emission, we don't know, billion or trillion years. This is my way of looking into the luminescence. Agree? Wherever color is there in the visible region is nothing but high energy absorption leading to light emission, which is luminescence. Remaining energy in the form of heat. Next one. So first sentence, you see that there are two common ways for this to occur: incandescence and luminescence. Incandescence is bulb, luminescence is whatever LED light or tube light or anything. I mentioned solar cell red with a red. So incandescence light and solar light, our scientists made such a way that solar light and incandescent light gives lambda in same way. So you keep your solar cell under the incandescent light, it will be detected, light is detected. You keep under the sun anyway, it detected. But to keep under the luminescence, that is LED light, no current, no EH phase generation. No EH phase generation. But fires are there, yellow color it gives. There is no EH. It is the burning of the organic materials. But incandescent from fire, some metal gives luminescence. Sorry, it detects the solar cell. But somebody put his solar cell under the fire. He is not getting it. Look nearer to the fire. It is detecting. What is detecting? Heat radiation. Yeah. Next one. Next one. Yeah. Research in light started 1,000 years back. The Arabic scholar published a book in those days. Next one. So these are the things. What is nano agreed word of needs? Finally, where we work is a small place. Next one. There are more than 15,000 devices using luminescence. You see that what are the LEDs? All luminescence. In that it may be electroluminescence or it may be fluorescence photoluminescence. Next one. So these are the things, classification of luminescence and the base of duration of emission. I'm not talking much. I talk only fluorescent, that is minus 8 seconds or less. What is happening in the solar system? Way or anyway. So absorption and emission is minus 8 or less seconds. So others we do not discuss now. Next one, please. So many areas of research title. So you will see here. Fireflies. 80% of sea creatures are luminous. Many minerals do emit luminescence. Many minerals you name it. So here, why this word I put many minerals? Some energies are absorbed by some minerals and giving supplements. But a very heavy energy is coming, like hard gamma, hard X-rays. Most of the minerals, including your glass, is fluorescence. A lot of energy is there, glass also gives fluorescence. That is what is glass? Silicon dioxide. If you see any mineral, 70% is silicon dioxide somewhere in the structure. Today, blood samples are there. You go to back to 25, 30 years. There, the technology is not that much. Today, most of the blood samples, most of the cancerous tissues, looking into that by putting some XY light, visible light, and giving the light in the less energy, and they conclude that this is type of the cancer. This is a blood analysis. And crime analysis. Yes, some murder is there, and blood samples, such stains are there, luminal This is old technology, almost 35, 40 years old technology. They put some luminal and 380 nanometer, 365 nanometer high pressure mercury vapor lamp light they will put. It will give green luminescence. So diamond purity and origin can be identified. Never starts, they never ends. What is your basic luminescent device? Morning you wake up before going to the bathroom, just where is my mobile? The backlight is luminescence. What are the lights are the luminescence? What is LEDs are luminescence? Maybe electroluminescence or photoluminescence. Next one. So many luminescence methods, including quartz. What is quartz? Only SiO2, the bond angle is different. So some of the metals I showed here. Jewelates are metals. Jewelate is also aluminous elements. Wherever silica is there, it is luminescence, gives luminescence at a different lambdas absorption. So now light emitting diodes everywhere. So 1996, the invention of high bright blue LED by Nakamura in Japan, when he was working with the India's corporation. From there onwards, by 2000, we got the first yellow dominated white light LED. So there, as I said, there are two technologies. Next one. So this is basic LED for physicists. Next one. This is most modern power, high power LED, 1 watt. Next one. So this is what we have to understand. The blue is a basic semiconductor LED, thin film coating. And on top, encapsulation is the materials, what we work, luminescence persons. So absorbing the blue, giving light in green, yellow, red. Finally, your output is red, white light. So by adjusting the colors, we can give color temperatures, various color temperatures we can have. A beautiful color LEDs are there. See that blue is whatever we are seeing, blue is the basic blue. Semiconductor LED. Others are, and red also semiconductor LED. Others are phosphor coated PCM. Next one. Oh, so many various semiconductor types and phosphor coating people are experimenting. And contactless light also come. Blue light is here. You put a glass embedded with or plastic embedded with our materials. It gives whatever the color you want. They're available. Next one. So this is the basic approach for solid state lighting. So left side is gold, right side is LED plus phosphor. So in when 1990, three LEDs, red, green, and blue together. They used to get only 5 lumen per watt. Today, in market, development of the materials, luminescence materials, and embedding, we are getting 150 lumen per watt. That is very high. Right? So theoretical calculation comes around 200. So we may achieve within near future. Next one, please. These are the trends people are discussing. Next one. As I said, the electromagnetic transitions, electronic transitions. So much so was explained when there was no computer, no calculator. So these are the things include triplet states. This is used in many ways. Next one. This is the blue LED. Just forget. Next one. See, that blue, our material, strontium, the calcium ciliate uranium 2 plus, use white. Next one. See that white? Next, red it use. Next one. So with that material we made LEDs in 2011 itself. At that time it was 70 lumen per watt. Now it is 150, double within 10 years. Next one. So this is the luminescence where the contribution of mind comes. Sky blue, so it is. Is it scattering? Okay. If scatters, why can't other colors? As a luminescence researcher, I looked into that. So this is the sky, which is a picture taken by me when flying at 12,000 meters, 12 kilometers above MSM. I traveled almost a dozen times, early morning and early, just evening, to see the sky. Whether other colors are there at any given moment. So finally the conclusions are going to come. See that. But where are other colors? Some green, some yellow, orange, red and red. Next one. So see this. We are going away from the mean sea level to up. What is happening? Height is changing. Temperature. The phenomena we will discuss next slide. So once height is changing, what is happening is your pressure is reducing. Okay. So these are some explanations. So from mean sea level to you go to 20th kilometer, your ozone layer starts. Once you travel around 12,000, that pilot announces you are for minus 50, minus 52 degrees centigrade. If you reach the 20th kilometer, below the ozone layer, temperature is minus 100 degrees centigrade. Thickness of the ozone layer is 10 kilometers. Just you go on the top of the ozone layer, temperature is plus 100 degrees centigrade. What is the difference? The minus, it is 200 degree gradient. Why it is? Go next. Go next. So, you see the temperatures. Room temperature is, see, same temperature you take is hardly mean sea level is 2 meters, 3 meters, around 20 degrees average. At 12 kilometers, 50 degrees centigrade minus. 30 is plus 100. At 100 degrees, 1000 degrees, 100 kilometers, 1000 degrees centigrade. 100 kilometers, 1000 degrees centigrade. Can you imagine this temperature? See, there is no pressure, the temperature is not felt. What is the temperature? So it is a bombardment of atoms. There are no atoms, so we don't feel it. Next one, please. I showed electromagnetic spectrum. I discussed only 10 per 14 energy. Gamma, ray of 1000 million electron volts, hitting a ion atom in the plasma form. Entire thing is in plasma form. Temperature is 1000 degrees centigrade. So we will get around blue 450 nanometers. But what about other energy? Other energy is converted as the heat. Next one. So same, lot of blue, lot of heat. Next one. So these are the color of the sky. The high energy particles like cosmic rays, gamma rays, X-rays, ultraviolet hit the nano dust in plasma form from solar system, enters the ionosphere and interacts with ions, gives rise the blue color more apart from other colors to the sky, and the excess energy released in the form of heat as well as infrared. This is due to temperature assisted ionoluminescence. There is a one small luminescence phenomenon, it is ionoluminescence. Okay. So these are the anyway hard gammas and others. Next one. Applications of electrons. Why this slide? Application of electrons. To generate, produce the electrons are very easy. The first electronic device, almost 100 years back, invented was valve diode, heater. We heat any metal, we will get heat. So that thermal electrons. So thermal electrons leads Einstein to get his Nobel Prize. Applications are many: tube light, LED lamp, X-rays, all semiconductor devices. See, electron hole pair is only the base for any of the. So to generate electrons, heat metal will get electrons. But control there is a different thing. Next one, please. We have seen X-rays over a diagram of the earth. So this is recorded by Indian satellite a decade back, I think 2011 they did. They put Earth in X-rays. Electrons. If you see an X-ray tube, what are they? Electrons is hitting the target, hitting the X-ray. That means production of X-ray is application of X-rays, application of electrons to produce X-rays, to produce electronic device, to produce light, okay, to produce anything, electrons are required. So in solar system, in a plasma form, electrons are there, the plasma ion is there. So their high energy electrons entered in that particular time gives rise the colors. See that bluish green, green and some yellow and red. So this is also a luminescence phenomenon. Next one. You see the moon, left side and right side. Moon rise, some yellow, red. Moon rise also you see the red. Why? Next one. I name this as a luminous moon. It's a clear sky, no dust, no clouds. If you can see the moon, you will get white light. Is it so or not? If you reflect any light, energy also reflected. Here, no energy is reflected. It is absorbed. Whatever the high energies are coming from the universe are absorbed by the minerals and giving the white light. So this is a luminous moon. Next one. So luminous Milky Way. But if you see any color, the visible region, it is a luminescence. Okay. Thank you very much. So finally what is my statement is, wherever you look into the light, unless until it is reflected through a mirror, mostly luminescence. Thank you very much.
Thank you for your motivating words, sir. Now, the first session of this beautiful day is coming to an end, but no need to worry. This is just a beginning. To extend and express our vote of thanks, I invite Professor Robert Joe, Head of Department of Nanoscience and Technology and Nanotechnology, University of Kerala, Trivandrum.
Good morning. Respected Professor PVR Chaudhary, Senior Executive Director, President, Medical Research Society, Singapore. Professor KVR Murthy, President, Lumen Society of India. Professor Gopakumar, Andover Examination University of Kerala. Dr. Ranjana, Head of the Department of Science, Department of Physics, of Science College, Random, and other faculty members from different colleges, universities, research college, and my dear students. I am very happy this morning to listen to an enlightening talk by Professor PVR Chaudhary. So, this is actually a challenge for the young physicists who are attended here for this seminar. So this is your responsibility for developing a materials that's sustainable for the society. So all the young physics students, you take this as challenge to develop the material which are sustainable to the society. So he has given an excellent talk. So on behalf of the organizing committee and my own behalf, I extend my sincere thanks to Professor PVR Chaudhary for this. Next, Professor KVR Murthy. So he has also given an excellent talk related to the luminous material. So this is also an enlightening talk. So I thank this. On behalf of the organizing committee and my own behalf, I extend my sincere thanks to Professor PVR Murthy for this. And next, the organizers of this meeting, Dr. is a coordinator, Professor Gobaguma, concluded examination. So he has taken a pain to arranging the conference in an excellent way. I stand up this time to offer the opportunity to thank Professor Gobaguma for this wonderful arrangement. And the convener of this conference, Dr. Anjana. So even though she is from Trivandrum, because all the arrangements is quite far away from this place. So all the arrangements in a wonderful way. So I also thank Dr. Anjana for this wonderful arrangement. And so even though we are in Trivandrum, so the other co-conveners, the head of the department of SD College and nearby places, and other Dr. Ragesh, I have seen that he took a lot of pain for since the meeting is a hybrid mode, so he has arranged in an excellent way. So on behalf of the organizing committee, I extend my sincere thanks to Professor Dr. Ragesh and other head of the department, other conveners for this excellent arrangement. And all the other faculty members from other different states and other colleges, I also extend my thanks to the on behalf of the organizing committee and all the research scholars and the students. I also thank you very much. Thank you so much. Thank you.